Hi. So today we're going to be going over some questions for integration and differentiation. Okay. So here's the question. It's from a past paper. Okay. So over here, let f of x is equal to x squared. So therefore, this is a function y is equal to f of x. And in this case, first of all, they want us to find a simple integral, which is the integral from 2 to 1 of f of x squared dx. So this is the integral from 2 to 1, and f of x squared is just x squared to the power of 2 times dx, which is the integral from 2 to 1 of x to the power of 4 times dx. And so that's x to the power of 5 divided by 5, which you're going to be evaluating from 2 to 1, okay? So this becomes 2 to the power of 5, okay, divided by 5 minus 1 to the power of 5 divided by 5. So 2 to the power of 5 is 32, and this is minus 1 to the power of 5, so this becomes 31 by 5. Okay? So that's for part A. Pretty simple, and this was for 4 marks. So in this case, that's an easy 4 marks for you. Okay? Now for part B, they're saying the following region shows a part of the graph of f of x. The shaded region R is enclosed in the graph of f. It's in between the x-axis, the lines x is equal to 1, x is equal to 2. So find the volume of the solid of revolution formed when x is revolved 360 degrees about the x-axis. Okay? Now, the way you can think about this, right, is that, so when you're thinking about the volume of revolution formula, so in the textbooks, what they end up saying over here is that if this is, let's say if this is y, and then this becomes x over here, and then let's say if this is a function y is equal to f of x, then, and let's say if you pick out 2 points, right? So this is b and this is a, then you can form a solid of revolution in between these points by using the shaded area, right? So the volume of revolution, you can form it like this, and then you get this sort of three-dimensional figure, right? By doing this volume of revolution. And in this case, the formula in the book states that the volume is equal to pi times the integral from b to a of y square dx. Okay? So if you're revolving a function y is equal to f of x, and if you're revolving it around the x-axis, then you integrate it in terms of dx and you find the volume v. Okay? Now, if you want to think about how to go about this, the way you can think about it is, if you look at this formula where the volume is sort of related to pi times the integral from b to a of y squared times dx, then if you see this, then this looks very, very similar to pi r squared, correct? Which is the which is the area of a circle, and then you're multiplying it by dx, if you think about it, right? If you remove the integral sign and if you look at the basics of it, then this y square times dx, right? It's sort of like you're taking the area of a circle. So you might be thinking that how are these two related, right? So the way these two end up being related, so if you want to get some intuition for, how we come up with this formula, is that, let's say if this is a function, right? So this is going to be x over here, and then let's say that we have a line. So we draw this line to be y is equal to 3, okay? And this is 0, 0. Now, let's say that if this is, I'm going to draw 2 dotted lines where x is 1 and x is 2, and we want to find the solid of revolution. So then the way you would go about it is, you would imagine it to be this way, right? You would draw a solid of revolution on both of these sides, and then you would connect these two, and this sort of becomes the three-dimensional volume you would be looking at. So in a way, you're sort of creating a cylinder, right? So if I make a cylinder like this, the volume of revolution comes this way. So this is your x-axis, up here is your y-axis, and then this is x is equal to 2 and this is x is equal to 1, right? So you have made a horizontal cylinder by using the volume of revolution formula. But if you want to find the volume of revolution, basically what you did for the cylinder was you found the area of one circle, which is pi r squared, and in this case, because y is equal to 3, this is just pi times y squared. Okay, so you found the area of one circle at the instantaneous value of dx. Okay, then after that you moved on to the second circle. You found the area of that circle, which is once again pi times the instantaneous value of y squared times dx. Okay, and then you kept on adding these circles consecutively over and over and over and over again. And once you kept on adding these circles, then you came up with the cylinder. Okay, so it's sort of like the instantaneous radius for that circle was y squared. So this is like pi r squared. So the instantaneous radius r comes out to be the instantaneous value of y. And then once you got the area, you multiplied it by dx. So if another way to think about it, right? So in this case, another way to think about it is, let's say if you have a circle, or let's say if you have a cylinder over here, right? So you would know that the volume of a cylinder would be given by pi r square h, right? So the way we get this volume to be pi r square h is that we have a circle over here. So we find the area of the circle. The area of the circle is pi r square. Okay. Then after that, we take another circle. The area of that circle is pi r1 squared. Then we take another circle, then another circle, then another circle, then another circle, and we keep on doing this until for the entire height of h. Okay. So if you have pi r squared circles, you multiply it by the height h to get your volume. So if you think about it, the volume is equal to the area multiplied by the height. So area is pi r squared. And the interesting analogy to think about it would be, for example, if you have those ham sandwiches, people take a ham slice, and then if you take multiple ham slices and put them on top of each other like this, you're creating a cylinder. So it's like you're taking ham slices, which are circular in nature. They're in 2 dimensions. You're adding up these ham slices on top of each other over and over again. And then based on that, you're creating a cylinder. Okay? Which is why you're going from a 2-dimensional object, which is a circle, to a 3-dimensional object, which is a cylinder. And so you're going from 2 dimensions, which is pi r squared, multiplied by h, to a 3-dimensional object. Okay? So that's how we would go about it over here. And that's why if you look at the area of a cube, for example, or let's say if the area of a cuboid, then you would have learned this in your previous classes, that the area of a cuboid, so if this is length and then this is the width and this is the height, then you would have learned that in this case the area of the volume of a cuboid is L times P times H, right? That's the volume of a cuboid. And so you just take this area, which is the length times the breadth, okay? And so what you're doing is that you're just doing it area times the height, okay? So you take one rectangle, which is what a cuboid is, you add it to another rectangle, you add it to another rectangle, you keep on adding them until the entire height h is reached, okay? So this is how we go from 2 dimensions to 3 dimensions, okay? So that's the main idea. And so in this case, another so this is more of a high level thing, but I think it would be interesting. Another way is, if you think of a circle, right? So the area of a circle is just given by pi r square, and you know that the perimeter of a circle is 2 pi r. Okay, so that's the circumference. So if you carefully think of a circle, in a circle, it's like you're simply just adding up a lot of circumferences together. So let's say that this is the starting point of the circle, this red dot, and then let's say if I have a circle of radius r, then you're just adding a lot of these circular lines which are perimeters, right? So you're simply just adding a lot of circular lines like this, okay? And then ultimately you get this huge circle, okay? So if you're going from the center and you're moving away from the center like this, right? So if you see this animation, it's like you're going from the one line to the next line, and based on this you're making a circle, right? So for example, so you get rid of the first perimeter, second perimeter, and like this, okay? So this is how you're making a circle. You're adding up a lot of circular layers or circular lines together, and you make a circle. So if you want to find how we get this formula, so if you want to know how we get this area of a circle, then basically the area of a circle can just be the summation of 2 pi r1. So r1 is the radius of the smallest point, plus 2 pi r2, which is a bigger line added to it, 2 pi r3, and then let's say multiply, go all the way times 2 pi rn. So this is like the nth radius, okay? And then what you can do is that you can take 2 pi as common. So this is going to be 2 pi times r1 plus r2 plus r3 dot 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 rn, okay? And this is going to give you the area of a circle, okay? So you're just adding up perimeters over and over and over. And in this case, there's a very handy formula for this. So there's a very handy formula that you need to know, okay? So if you have numbers which are, let's say, going from 1 to 2 to 3 to 4, and then let's say to 10, then if you're adding everything together, then, and let's say that if these are n numbers, then you can see that so in this case, the sum of these numbers is of the form of n times n plus 1 by 2, okay? So this is, so like in terms of a high level thing, if you have n numbers, and you're incrementing them by 1 or by a specific value, let's say you increment them by 1, then in this case they become of the form n times n plus 1 by 2, right? So in this case, this would be 2 pi times r plus 1 by 2, okay? The 2 and 2 cancel, so this is pi times r square plus r, which is approximately of the form pi r square, okay? So we're not looking at the specifics, we're trying to sort of get the approximate thing, right? Because I'm not trying to give you a proof. I'm trying to give you an intuition for how you can go from area to volume, or how you can go from one-dimensional lines to two-dimensional area. So for example, over here we went from one-dimensional circular lines to two-dimensional area. So for example, this one-dimensional line was 2 pi r, and we saw how we went from 2 pi r to a circle which is pi r square, and then we saw that how you go from pi r square to an entire cylinder by doing pi r square h, okay? And in this case, this is sort of like pi r cubed, approximately, because you have another dimension h. So if you see, you go from degree 1 to degree 2 to degree 3. Okay? So so if you go from one dimension to another dimension, then you're increasing the number of degrees, and that's what we are seeing over here. Okay? Now, the main thing for this is we can look at we can go back to our question and sort of see the intuition for the formula for solids of revolution. Okay? So when we look at the solids of revolution, we see that the formula for that, so the formula for solids of revolution, or the volume of revolution, is going to be pi times the integral from b to a of y squared dx. And you can see approximately this is pi y squared times dx. So dx is one dimension, and then y squared is two dimensions, right? So that's how you get volume, because as you know, volume is in three dimensions. So 2 plus 1 is 3. So the way you go about it is that, once again, if this is y, and then let's say that if this is x, and you're given by this function y is equal to f of x, and then they give you a certain area which is b and a, then you first make a volume of all you're doing is that you're adding up concentric circles. Okay, so this circle over here, this is just pi y squared times dx. Then you're adding it to another circle, which is once again pi y squared times dx. Okay, so you keep on adding these. So it's like you're adding, so you're finding the area of a circle, which is pi y squared, and then you're adding them, okay, many times together, and this entire thing is done dx times. So this is like pi y squared dx. Okay, so between b and a, you're taking these concentric circles, and then you just keep adding the concentric circles with each other. And what you can see is that the radius of these circles, so if this is one circle you're drawing, then the radius of the circle keeps on fluctuating, right? So some circles are bigger, some circles are smaller, because this value of y is equal to f of x is going to keep changing for different circles like these. Okay, and so that's why you would use integration in this case, because the value of y is changing. So it's the integral from b to a of y squared dx multiplied by pi, and this should give you the formula. Okay, so that's the main thing. You're finding the instantaneous y value for different circles. Okay, and then you're just integrating through the entire region. So if this is b and let's say that this is a, then you end up integrating through this entire region to get the volume of revolution, right? So this was basically an overview of how you can go from circumference to area, and then how you can go from area to volume. Okay, all right, so now what we can just do is we can just simply plug in the formula, right? So the main thing with these questions is you should understand the formula. Obviously you can plug and chug the equations, but you won't understand the meaning behind it. And later on, let's say if you go to university, then most of the questions they require you to know deep understanding of the subject matter, right? So anyways, the main thing is that they want you to find the solid of revolution over here, right? So we found part A, which is the integral, which is this integral over here, which is 31 by 5. And then for part B, you're given a graph of f. Okay, so they want you to find the volume of solid formed when this r is revolved around the y-axis. About the x-axis. So the solid we are sort of looking for is something like this. Okay, so this is the solid we are looking for in this shaded region. All right, that's the solid that we're going for. So therefore the volume is just pi times the integral from b to a of y squared dx, and this is pi times, so the value of b and a is just 2 and 1. So this is pi times, the integral from 2 to 1 of f of x squared. So this is, so f of x is x squared, right? So if y is equal to f of x is equal to x squared, then this is just pi times the integral from 2 to 1 of x squared whole squared dx, which is just pi times the integral from 2 to 1 of x to the power of 4 dx. And as you can see, we already calculated this in part A. So we got 31 by 5. So then this is pi times 31 by 5. That's the volume we would be getting. And so in this case, this becomes 6.2 pi, and that's your answer. Okay? So this is how we looked at integration and solids of revolution. And if you saw over here, we did some, we went into seeing how areas and volumes and perimeters are formed, right? So yeah, the main thing over here is if you want to find the volume of the solid of revolution, so if this is a three-dimensional solid, so this is the solid we would be looking at. This would be a three-dimensional solid, okay? If this is a three-dimensional solid, then all we did was we took the first circle, which is pi y squared. We added it to the second circle. Then we added it to the third circle, and we kept on going until we reached the end point. And so this would be pi y squared multiplied by dx times, right? Which is a volume, because as you saw, volume has 3 dimensions. So dx is 1 dimension, y squared is 2 dimensions, then 2 plus 1 gives you 3. Okay? So that's the main idea. Alright then, good luck.